Hello everyone, good morning. Today we're going to continue 9-2 and 9-3, day 2, and we're going to continue solving rational equations. Again, rational equations are equations that have fractions. So we will be solving it using the algebraic method today. Yesterday you learned how to graph the rational equation using decimals and a graphing calculator, and then look for the intersection for the two functions and then find the solution. And we also verified it using algebra, that those are the solutions. So today we're going to just transition into solving algebraically specifically. So let's take a look at some notes regarding solving algebraically solving rational equations. So first one, rational equations can be solved algebraically by multiplying through by the LCD. So here's a very important concept using the LCD, which is least common denominator. And I'm sure you guys have heard of that before. You've learned it in elementary school or middle school. So we're going to take a look at how powerful the LCD is that will help us to solve easily for the rational equations. And then after you apply the LCD, you should be able to solve the resulting polynomial equation, because we would have no more fractions and no more rational equations. Okay, so that's a very important concept, the LCD. Here's another note. Sometimes an excluded value of the original equation is a solution of the polynomial equation. And in this case, the excluded value will be an extraneous solution. So if when you're solving the rest of the polynomial, you get a solution, but then it's excluded in the original equation, you cannot use that as a solution. That's basically what that means. And also, an extraneous solution are not solutions of the equation, so you must cross them out. So if you find anything that is extraneous, or something that you gain extra, that is because by the word extraneous, it has the word extra. So it's kind of like an extra solution that you gain that is not necessarily the solution. We need to cross it out and exclude it. Okay, so that's a lot of writing, and let's go ahead and practice using a specific problem, so that way you know how to actually apply what we just learned. And let's begin with the basic concept of the LCD. So we call that in elementary school or middle school, you guys already explored and the idea of finding the LCD. So for example, between 2 and 4, because I know that 4 is the number that 2 can multiply by 2 will make it look like a 4, and then 4 can times 1 will look like a 4, then I know the LCD is 4. Likewise, between 2 and 3, because they are different factors, we need to multiply the two of them together. So 6 is the LCD. So we're going to take it to a little higher level, which is here. We are the difference between the IM3 rational expressions and the elementary school, middle school, is that you're going to start seeing variables like x and x squared. That is the difference. Okay, so let's go ahead and take a look at the bottom of the fractions for number 1a, and we can see that there's 5x and 10. So let's focus on the denominator, because LCD is about the denominator, right? So we're going to just kind of rewrite the bottoms as factors, different factors. 5x is made up of 5 and x, so those are the two factors. 10 can be written as 5 and 2. And so the common factor here is 5. So we're going to write that down, and we're going to write all the different factors. So x is different, so that needs to be on the list. And then 2 is also different. I don't see that anywhere else, so I'm going to have to write that down. So together, if you multiply 5x and 2, you will get the common denominator, or least common denominator, LCD, is 10x. Okay, let's practice another one. So 4x can be rewritten as 4 and x. 3x squared is 3 times x times x. So 4 is a different factor, so we will write that down. 3 is also a different factor, so we're going to multiply that. And then we have one x that is common, so we're going to write that down. And we also have a second x that looks like it's different than the previous one, so we're going to add that to the list. And so together, the LCD is 12x squared. Notice that I can make the 4x here look like 12x squared by multiplying by 3 and x. And I can easily do that on the top two to keep the fraction the same, but important thing is on the bottom, I can make it look like the LCD. So that's what makes this the LCD. And then I can make the right hand side look like 12x squared by multiplying by a 4. So that is how I can make use of the LCD. And let's take a look at the next problem. Notice that we have the factor of x plus 2. So you need to get used to seeing that these expressions that are joined with a plus and a minus, they are actually different factors. So think of x plus 2 as one factor and x minus 3 is one factor. So they don't look the same. Just because there's an x in common does not make them like common factors. So they do not have anything in common. So the LCD excuse me, would be the two of them multiplied together. So it's x plus 2 and x minus 3. And that is the LCD for that one. And the next one, whenever you see like a quadratic expression, you need to actually begin by factoring it out. So we have x from the factoring skills you have in the past. You should know that that is x plus 1 and x plus 2. So if you look at the parentheses, each parentheses as a separate factor, we will have actually 1, 2, 3 different factors. So we got to multiply all of them together. So it is x plus 1 plus x times x plus 2 times x plus 3. And that is the complete list of the LCD. Okie dokie, we have tried several problems together. So now it is your turn to try out some of these problems. So go ahead and pause the video and try the problem before you actually look at the answers. Okay, hopefully you've had a chance to try the problem. So let's take a look at the try it problem part A. So we're going to rewrite between 6 and 2. You can start seeing the pattern that, you don't really need to like list the factors out all the time. So sometimes you can just look between 2 and 6. I know the bigger number, 2 can go into 6 and 6 can go into 6. So the LCD for that one is 6. And then we also have x as a second factor. So we can just multiply the x. And so that makes the LCD 6x. And let's look at part B. So between 3 and 4, from previous class, you should already know that between 3 and 4, the LCD is probably 12. And so x squared and x squared look the same. So I can just write down the whole thing of x squared, and that makes the LCD for part B. Continuing, we're going to look at part C, and we have two different factors. And so x plus 5 is one factor, and x minus 3 is a second factor. And so therefore, we multiply the two of them. That will become the LCD. And next one, we have two quadratic expressions. So the first thing we need to do is factor the two of them. So we have x plus 2, x minus 1 here, and then cross it out. We have x minus 3 and x plus 2, and we can cross it out. So actually, I do see one common factor, so I'm going to write that down. So that's the common factor. And then I see x minus 1 that is different, and then x minus 3 is also different. So we have three different factors that make up the LCD here. And that is the end of that one. So let's go ahead and continue using LCD to solve for the different problems. So number 2, example 2, the LCD in this case, because there's only one factor and they look exactly the same. So the LCD is actually x minus 4. Now from the LCD, you can obtain the excluded value. So the excluded value is, remember, excluded value from the previous lesson is whatever makes the bottom 0. So in this case, it should be 4 because 4 minus 4 is 0, right? So we can actually also say that x cannot equal to 4 because when x is 4, we're going to make the bottom 0. This problem is special in the sense that bottom looks exactly the same. So when you have two fractions set up by an equal sign, then whenever the bottoms are equal, the top should equal. So we can just kind of like, eliminate the bottom because they're equal to each other, right? So that would mean the top 4x has to equal to 2x plus 8. You can also think of it as the fact that if you multiply both sides of the fraction by the LCD, which is x minus 4, you will be able to cross out the bottom and you would still end up with 4x is equal to 2x plus 8. We're going to continue solving for x by subtracting 2x, and we have 2x equals 8, and finally divided by 2, and we have x equals 4. But ladies and gentlemen, we got to cross-reference with our excluded value. Recall that the problem originally says we cannot have x equal to 4 because it will make the bottom 0, right? And we found the solution to be x equal to 4. So the conclusion is we cannot use the 4 because it's excluded. It's an excluded value, so we cannot count towards the solution. So what is our solution? The only answer we found was 4, and it's excluded. So the answer to this problem is there is no solution because the only answer that we found is excluded. So that is the final answer. Even though we did a lot of work to get answer x equal 4, it does not count. So we are left with no solution for that problem. Let's move on and take a look at part B. In this problem, again, we see a quadratic expression. So we're going to try to factor that first, x minus 2 and x plus 1. And we can see that there's an x plus 1 in common. And there's also an x minus 2 that is different. So we're going to need both of them. And so, therefore, we can get the excluded value from here. So what is going to make this problem 0 on the bottom? Well, when x equals negative 1, right? Because if you subtract 1, then you're going to get 0. And so x cannot equal to negative 1, or it cannot equal to 2, because when you put 2 here, it's going to give it 0. It's going to make it a 0. So therefore, we have two excluded value here. And now we're going to multiply both sides of the equation by the LCD to get rid of that. So if you just multiply LCD here, x plus 1 times x minus 2, then guess what? The x plus 1 will cancel out from the bottom, and you have x times x minus 2 left equals the right-hand side is multiplying by x plus 1 and x minus 2, the LCD. Both of them will actually cancel out. We got nothing except for 5x minus 10 left. So that is the whole idea of using the LCD. So hopefully you guys understand that concept, and you see how nicely it gets rid of all the fractions, right? So we only have a one-line problem now. We're going to distribute the x through. So x squared minus 2x equals 5x minus 0, and we're going to 0 it out on one side. And so we have x squared minus 7x plus 10 equal to 0. And we can just actually factor this into x and x. The signs are the same. Both of them are minus. So minus 2 and 5. 2 times 5 is 10. 2 plus 5 is 7. And so x is equal to 2 and 5. And we're going to cross-reference that with the excluded value. So notice here that we have x cannot equal to negative 1 or 2. Well, 2 is actually one of the answers that we found. So we got to cross it out. That leaves the only answer is 5. So the answer for this problem is 5 only. And 2 is called an extraneous solution. Okay, and it's also excluded, right? So it is an extraneous solution. So the only solution is 5. And now it is time for you to try one. So go ahead and pause the video and try it. Hopefully you've had a chance to try the problem. We're going to start with the bottom. I see that there's a common factor here, 3. So I'm going to count that as one factor. And then there's also a common x all across. So we're going to also include that. So the LCD is 3x. To find the excluded value, we got to think what is going to make the bottom 0. So we actually have x cannot equal to 0, because when the bottom is 0, it's going to equal to 0, right? So we cannot have x equal to 0. So now we're going to multiply every single term by the LCD, which is 3x. So 3x, remember, every term needs to be multiplying by 3x. So the x cancels out, and the 3 and the x cancels out over here. And then also on the right-hand side, 3 and the x also cancels out. And so after you cancel out the common terms, we have 3. So let's go ahead and write that down here. We have 3 minus, everything is gone here, but don't don't forget, be careful here. We have a minus sign, and we got x minus 2 equals 1 because everything is gone on the right hand side. You just have 1 left. So once again, the x crossed out here, we only have 3 times 1, which is 3. And then here, everything is gone except for the x minus 2. But don't forget, there's a negative here. So that's why I put the parentheses there. And now we're going to distribute the negative through. So it's 3 minus x plus 2 equals 1. And 3 plus 2 is 5. We got negative x plus 5 equals 1. Subtracting 5, and we have negative x equals negative 4, and therefore x equals 4. And before we say this is the answer, we're going to cross-reference with the excluded value. The only number that is excluded from the solution is 0. So therefore, x equal 4 is a valid answer. So 4 is the solution in this case. Hopefully you got it right. Alrighty, let's try the next one. So go ahead and pause the video and try it before you actually check your answers. So hopefully you've had a chance to try the problem. Let's go ahead and start with the LCD again. So in this case, we have two different factors. X plus 3 is different and x plus 6 is different. So we got to multiply the two of them together to get the same, the LCD. And so the excluded value in this case is x cannot equal to negative 3 because that would make the bottom 0, right? You see it? So it cannot equal to negative 3 or negative 6 because that will make the bottom 0 too. So two excluded values. Next, we're going to multiply both sides by the LCD. Another way that you guys can think of doing this, usually a lot of times there's more than one way to do the problem. When the problem only has one fraction on both sides, there's a second option. Instead of multiplying the LCD, it's kind of like you can cross multiply. You can think of that as cross multiplying. So you can have a times x plus 6 is equal to x plus 1 times x plus 3. And then we're going to use the math. Notice that if you would have multiplied the LCD, you would have gotten the same thing, okay? So we're going to distribute 8x, 8 plus 8x plus 48 equals, foiling the right-hand side, x squared plus 3 plus 1 equals plus 4x, and then a plus 3. And then we're going to zero one side out. So let's go ahead and zero out the left side. And that leaves us 0 equals x squared minus 4x minus 45. And we're going to try to factor that. So it is x and x. We want negative 4, so we're going to have minus 9 and plus 5, right? 9 minus 5 is 4. 9 times 5 is 45. So the zeros are x equals 9 and negative 5. And we're just going to double check with the excluded value. It's negative 3 and negative 6, so neither one of these answers are excluded, so both of them are actually valid answers. And that is the end of that part. So let's go ahead and do part C. And this one has the bottom also has squares. So let's factor out the GCF. We have x times x minus 4. And that's also x times x minus 4 here. And so the LCD, there's a common x in all of them. So that would be x. And then there's a second factor, which is x minus 4. And that's all, the LCD. And for the excluded value, x cannot equal to 0. Otherwise, this whole thing would be 0 on the bottom. So it cannot be 0 or 4, because if you let that equal to 4, you will also have 0 on the bottom. So both of them will make the bottom 0. So those are the excluded value. And now we're going to actually multiply the LCD because we actually have 3 terms. So let's multiply the LCD of x times x minus 4. And then x times x minus 4, all 3 terms, all 3 terms, sides, everything gets to multiplied. So we're going to cross out both of them here, and both of them also cross out here, and the x crosses out here. So let's bring the answer over here. What do we have left? We have 5x minus 5 minus 5 by itself, everything else is gone, equals we have 1 times x minus 4, which is just x minus 4. And let's go ahead and combine like terms. So we have 5x minus 10 equals x minus 4 subtracting x and adding 10. So I have 4x equals 6, and then we're going to divide it by 4. So we have x equals 6 over 4 or 3 over 2, and let's see if that is excluded or not. So the excluded values are 0 and 4, and so therefore x equals 3 over 2 is a valid answer. And so that is the final answer. And that's the end of all the problems. Let's take a look at the discussion question. How can you tell whether a solution of a rational equation is extraneous? So what you can do is we are going to, when you finish solving for a solution like we did right now, you can cross-reference it with the excluded values, because if it is excluded, then you know then it is extraneous. But if it's not excluded, then it's a valid answer. So that's how you can distinguish. And that's the end of day 2 for 9.3. Go ahead and get started with your assignment, and have a nice day. See you tomorrow.